using the Tilt 5 wand with the Unity input system. Now, Unity offers a variety of different ways to gain input from devices, and I want to talk about just a couple of them and how they interact with the Tilt 5 system. I've got here an empty project, one where I've just imported the Tilt 5 SDK. This is running the latest 1.30 version, and we're going to go over some of the different ways that you can get input using the Tilt 5 wand. So, first things first, we're going to get our scene set up with the Tilt 5 prefab. We're going to need to get ourselves some kind of object to interact with, and I'm going to set up some additional components just to show that the inputs are working. We're going to do our first material is just going to be a nice bright red color. We're going to make a second one. Let's rename that. And we're going to give it a nice bright green color. Something to just help differentiate once we start using the inputs. Now, the first way we're going to show inputs here is going to be using the classic Unity input system. I'm going to go ahead and make a new script here. And we'll dive right in. Now, traditionally in Unity, input is done on a polling basis. What this means is you need to ask Unity what the state of a certain device's button is in order to find out whether something has been pushed or not. Now, the initial implementation of Tilt 5 input mirrors this. We have a series of functions called try, get, button down. Should probably put this inside of a function right there. That take a couple of different parameters to try and get more information on a button. Let's say I want to get information on the one button of my wand. That is the button directly beneath the joystick on the left. Specify the button. Then I need some kind of variable to hold the result of whether it's been pressed. I need to specify which controller I want to use. With Tilt 5, you can have both a right and a left controller. The right controller is the one that connects to the player first. So I usually default to checking the right player in the right wand in most scenarios. And then we have the player index. Now, the player index defaults to player 1, but if you have more than one headset plugged into the same system and you're trying to check inputs from different players, you can always change this number to be 1, 2, 3, 4, any of the other players. Now, an important stipulation is why we're using try get button down. We also have a get button down function here. The big difference is sometimes the wands don't exist. If they're not connected yet, for example, trying to get a button for a specific wand may result in an error. So instead, we use the try get button down, which returns true only if it was able to get the value of a button. That way we can check to make sure we're actually getting some kind of result in our one pressed variable here. Next up, we're going to need to actually do something with this input. So I'm going to give myself a couple different parameters here to work with. We've got our cube. We're going to do our first material, our second material, and let's go ahead and just change the cube's color. So we'll do cube.getComponent mesh renderer dot material equals our first material. Now, all we have to do is specify those values inside of Unity. I've got my empty game object here. I'm going to throw the old input script on it, set our cube, set our first material, set our second material. Now, if I give it a run, I already have my glasses and wand connected here. We'll see everything come up in the game. And just like that, the color changes. One important thing to be aware of is simply checking if you were able to get the button doesn't actually give you the result of whether it was pressed. You also need to check the value of your output variable, in this case 1 press. Otherwise, you're just always going to get a value of true. So with that in place, let's give it a check. Notice that it starts out white, but as soon as I press the 1 button on my wand, it quickly changes to red. What if you wanted a separate button though? Maybe you want to be able to change the colors back and forth. Well, that can easily be duplicated. We can set ourselves a second button here. We'll get button 2 instead. Make a different output variable, 2 pressed. We'll check if 2 is pressed, and we'll change the material to 2. Just like that, we've added inputs for a second button. Let's give it a test. And if everything is working properly, we press 1 to change it to red, 2 to change it to green, and we can flip back and forth whenever we want to. Now, in addition to buttons, the Tilt 5 wand also comes with a joystick. Thankfully, joysticks are just as easy to access as the buttons. Let's say we wanted to get the exact value of the joystick from our right wand. We're going to do an if tilt5.input.try get stick tilt, and we're going to need to specify an out vector2, we'll call it joystick for now. We're going to specify the right controller and player 1, because I only have one glasses connected right now. And let's say we just wanted to make the cube move whenever we move the joystick. Well, we're going to say cube.transform.translate, and then we're going to apply, in this case, the joystick.x to the x value of our translation. We don't want to move anything in the y direction, and then we're going to do the joystick.y in the z direction. Now we have to be careful because we are working in an update loop. We're going to want to make sure to multiply everything by time.delta time. This makes sure we're not flying all over the place every time we're trying to move. Notice that this is happening once every frame. We are checking all of the values. And if we tried to move every frame at the value of the joystick, which is a value between -1 and 1 in both the x and y directions, then we would find ourselves shooting off the map really quickly. But with this, we'll go ahead and give it a test, hit play, and let's see what happens. Just like that, our cube is moving. Now, I notice this cube is moving a little bit slow. I think I'm going to fix that real quick. We're going to come back into our script. We're going to add an extra speed variable. And we're going to multiply everything by speed here. Just give us a little bit more zoom. Make sure our speed is set to something reasonable, like 10. Give it a run. And as you can see, cube is moving around the world nice and easy. Just like that, we were able to get inputs using Unity. Next up, I want to talk about Unity's new input system. From 2019 forward, Unity has created a separate package that they allow people to use that allows a different style of input management. This one is much more state-based and requires checking against the state of a input device as opposed to trying to pull the device for a specific button on each frame. Now, I'm going to go ahead and get this input system package installed real quick. Should be a really quick install most of the time. It will ask if you want to enable the backends. That's totally okay. It's going to restart your project. Should take just a second. Alright, now that we've got the input system included, we're going to go ahead and make a new script. I'm going to call this new input system. Now, Tilt5 devices also behave well with the new input system, so we're going to go ahead and import the input system here. And much like our old input system, we're going to need a couple of extra variables here. I'm just going to grab them real quick. I want to add an extra material for something a little bit later. Now, unlike the old input system where we had to try and check if an individual button was pressed on every frame, this can get a little wordy and expansive in your script pretty quick if you're checking for all kinds of different buttons. We have a slightly different approach with the new input system. With the input system enabled, we can access what's called wand devices. And we can try and get a specific wand device. All we have to do is specify a player number, a wand index, in this case, once again, the right wand for player 1, and then we just need to specify some kind of out device that's going to hold our wand device object. Now, if we're able to get a wand device, meaning there is a wand connected and it exists within Unity, then all we have to do is check the state of any of that device's various buttons. We have a couple different options here. In this case, I'm going to check the was pressed this frame. Because this is running every single frame of Unity in the update loop, this will be something that fires exactly once. It will check if the one button was pressed exactly on this frame, do something. In this case, we're going to grab the same cube and we're going to change its color to red. If I want to check a second button, well, that's a much faster check. All I have to do, change this to the 2 button instead and change what its input does. Just like that, I've already got inputs from the buttons. Let's take a look. I'm going to come back over to my input manager right here. We're going to disable the old input system. Throw in our new input system. We're going to give it a material 1, material 2, the cube, and we won't worry about speed or material 3 yet. So, just to see it all working, we'll give it a play. And just like that, pressing 1 and 2 changes the cube back and forth just like before. Now, you might be wondering, how do I get stick values? It's a good question. Thankfully, it's just as easy, if not even easier. We're going to go ahead and take the cube.transform.translate just like before, and instead of having to pull a stick value, we already have the stick value from the device. We ask the stick, we say we want to read the value from it, and we want the X component of that joystick first. We want nothing for a Y value, and then we'll do wand_device.stick.readValue.Y for a Z component of this translate vector. And just like that, our cube will be moving. You may notice this cube is moving incredibly fast. That is because we did not factor in our time.delta time. Very important to factor in the change in time, as this is something that is being pulled continually over every frame. And then we can go ahead and throw our speed in there as well. Come back over here, check our input, set the speed to 10, 10, and give it a go. There we go. Now it's moving at a much more natural speed. Now, one extra little thing I'd like to show is, in addition to checking if a button was pressed on a specific frame, we can also check if the button is being held, or in some cases, not held. For example, if I want to see if neither the 1 nor the 2 button is pressed, then I can check if the wand_device.1 and wand_device.2 is pressed values are both false, and if they are, we can set our cube back to a material 3, which doesn't exist yet, so we'll make that real quick. This one, duplicate it. Rename it material 3. Make sure this one is a nice white color, kind of the basic default color for it. Throw that in there, and give it a run. Now, as long as we're holding the 1 button, the cube stays red. As long as we're holding the 2 button, the cube stays green. But whenever we release 1 and 2, the cube goes back to its normal color. Just like that, we have inputs using the new input system in Unity. One final topic I want to go over is how to use action maps with the new input system. Sometimes, instead of trying to check the state of a wand device, you simply want to fire an event or send a message when a button is pushed. Now, setting up action maps is a little bit more complicated, but I'm going to show you how to do it step by step. First thing we're going to need is a player input manager. This is very important because this is how we're going to be able to map individual events to specific players and their specific wands once the game gets going. Now, it's important to change the join behavior on your player input manager to join players manually because we're going to be creating an object that joins into the player input system all on its own. Next, we're going to create an empty game object here. I'm just going to call it the player prefab object. First thing I'm going to give it is going to be a player input component. Now, right now, there are no actions for this player input, but I'm going to create a new input action set. Now, the only action map we care about right now is going to be this player action map, and the first action we're going to do is we're going to work on the move action. I'm going to remove some of these old bindings from other devices. We don't need them. We're going to go ahead and add our own new binding. We're going to take the path here, XR controller, tilt 5 wand, and we want specifically the right tilt 5 wand and its stick value. And just like that, if we specify the control schemes it maps to, anytime we move the stick, its value is going to get passed into this move action. Go ahead and make sure that auto saves. Next up, we need to create a script to receive these messages. So, let's make one more C# script. I'm going to call this new input system action maps. Go ahead and open it up. Just like before, I'm going to grab some of these useful variables and throw them here. One difference compared to how we do this in other systems is we're going to have to find the cube object manually because the script is going to exist on a prefab. We cannot specify objects in the scene on the prefab. We have to manually find them through the find system. This is just one of the easy ways to find a game object to modify. Next up, instead of using the update function, we are going to create a new function to receive the message. It's going to be the onMove function. Oops. It's going to be a private onMove. The only parameter it's going to have, actually we don't need it private. Only parameter it's going to have is going to be an input value. Important to remember to incorporate the new input system. If you don't include it, you won't have access to those input values. Now, when we receive the move command, much like we did before, we're going to do a transform translate. But instead of using one device here, we're going to do value.get, and then we're going to specify the type we're getting, which is a vector2, because this is a joystick input, x, and then same thing for the y. Now, with all this in place, we come back over to Unity. We look at our player prefab. we throw this new input systems with action map script on it. We make sure to set some of the important materials here, material 1, material 2, material 3. We'll use those in a second, and the speed. We make sure that this is set to send messages right now. Send messages means certain messages, such as on move, will be sent to the same game object that this player input component is on. And that's important to us because when the on move message is sent, the script receives it and it calls the on move function. Notice that the name of this is simply the name of the action here with on before it. So let's make sure our old scripts are off. We only have the input manager and this player prefab. We're going to drag it out to make an actual prefab in the scene. Now this is one of the most important parts. In order to make the action map system work properly, we need to make sure that this player input prefab gets spawned when a new pair of glasses connects. In order to do that, we come to Tilt5 Manager and we have a little field here called the object template. If we throw a prefab in there, anytime a pair of glasses gets created, this object is going to be created underneath it, mimicking all of these values for the script. So if I give this a play, we should see the cube moving, which it's not, which means we have some bug. I'm going to take a look real quick. I'll be right back. Alright, turns out everything was working just fine. There was just a small delay in the wand being recognized by the input system, but now we have movement with the joystick working. Let's say we want to do the color changing as well. Well, we will go back into our action maps here. We're going to add a couple extra actions like change color 1, and we'll add one more, change color 2. I'm going to go ahead and bind this one to XR controller, Tilt5 wand, right hand, 1 button. And the same thing, this is going to be bound to the 2 button. Now, an important note, instead of binding it to a specific hand like I have here, you could bind it to one of these values for the generic Tilt5 wand. The important thing to remember there is if you do that, it will take the input of either wand. So if either a left or a right wand has the 1 button pressed, it will trigger that specific action. Make sure we apply this to all of our schemes. And next up, we need to change our scripts to handle this up next message. And we're going to do an on change color 1. And once again, it is going to take an input value. And this time, we're going to check if value.isPressed. This is how we check if a button has actually been pressed on a specific frame. Then, just like before, we can set the cube's mesh renderer to a new material. And if I wanted to do another one, let's say our 2 button input, do on color change 2, check if it's pressed, and change the material to 2. Just like that. You give it a test, and there we go. 1 and 2 change the colors of the cube. The joystick still moves the cube around. Now, one final system that is sometimes used with the action maps is instead of sending messages, some people like to fire events instead. They like to call a specific function when an event is fired. And I'm going to show you how to handle that real quick. So instead of sending messages, we're going to invoke Unity events. You'll see here, we still have those move, change color, and change color actions. The only difference here is we need to specify an object. And you'll notice we don't have any useful functions to call yet. We're going to go ahead and create those for ourselves real quick in this script. We're going to make the first one, we'll call move cube. Now, big difference here is instead of taking a input value, we're going to take an input action dot callback context. This is specifically the value that's coming in with the event. And this is useful for us because we can take our translate call here, and instead of value, we're going to do context dot read value, specify the type, which is once again a vector2 because this is our wand, and we'll get its x component. Make sure your brackets are right. Next up, we do the same for y, and just like that, we'll instead call this moveCube function instead of sending a message to invoke one of these. I'm going to quickly make a set of functions for changing the color, show how you can do buttons as well. I'm going to do change color 1, and we're going to do once again the input action dot callback context, call context. And in this one, we're going to check if context dot read as button. Now, as long as we're reading the context as a button, it will give us either the true or false value of whether that button is pressed. And because the context is specifically coming from the one button being pressed on the wand, if the one button is pressed, we should be able to read that value as true. And if it's true, we will once again change the cube's material to red. One final function, instead of 1, 2, and we'll change the material to 2. All right, let's give it a test. We're going to need to make sure here we specify our moveCube function. This one is going to need to be our change color 1 function, and finally change color 2 needs to be our change color 2 function. All right, with everything set up, we give it a run, and we move just like before. The 1 button changes us to red, the 2 button changes us to green, and just like that, we've set up inputs once again using the Tilt 5 system. Once again, this has been Justin, and I hope you have a lovely day. Bye.